So my first export is always an MP3 file, and on this MP3 file, I don't change the sample rate, I don't change the bit depth, and I don't dither. Today we are going to address a topic that is as old as the computer itself and has totally refused to go away. Hello guys, fellow audio engineers, you're welcome to the video. And if you're a returning viewer, you're welcome back to the channel. So guys, I recently noticed that the conversation on dithering has resurfaced again. I genuinely thought this was a thing of the past already, but then I also understand that every day a new audio engineer is born who obviously hits this roadblock and wants to understand what the rules are and or what the science is. The main problem with this particular topic is whenever you get on research mode and try to understand, the rabbit hole always gets deeper and deeper, and because of the too many concepts involved and a lot of audio terminology that you probably won't understand as a beginner or even sometimes as an intermediate, you end up more confused than you were before you started digging. I actually had to do some more research again myself all over just so I could articulate my thoughts properly in this video, and I was shocked to still find myself learning some new things, So, if you want to just understand what dithering is, when to dither and when not to dither, this video should clarify your questions and doubts so you can just focus on making music, because trust me guys, I've been there and I understand nothing kills creativity more than stressing about whether your technical settings are right or not. So basically, what is dithering? Audio dithering is the intentional addition of low-level random noise to a digital audio signal used as a final mastering step when reducing bit depth. It prevents ugly digital distortion called quantization error by masking rounding errors, resulting in cleaner, more natural sounding audio. You see, the key line here is this last line, resulting in cleaner, more natural sounding audio. This is what we all are looking for, obviously. Now, you're probably wondering, how many times then do I have to dither? The simple answer to that is only dither once. I believe you've already heard this phrase only dither once more than 1,000 times, but then the next question that always comes is when to dither and when not to dither. The simple straight answer to that too is only dither when going from a higher bit depth to a lower bit depth. Example could be going from 32-bit to 24-bit, which is rarely and I personally don't practice, but most commonly when going from 24-bit to 16-bit. So basically the decision of whether to dither or not is purely driven by a change in bit depth, which is strictly when going from a higher bit depth to a lower one. From everything we've discussed so far, you should normally already be asking yourself by now, so what actually is bit depth? Bit depth in digital audio represents the number of bits of information in each sample, directly determining the amplitude resolution, dynamic range, and noise floor of an audio signal. This defines how precisely a sound's volume can be recorded and played back. Higher bit depths like 32-bit float and 24-bit provide more amplitude values, reducing noise floors and allowing greater dynamic range compared to 16-bit, which is standard for CDs, or was 8-bit. As you can already tell by now, bit depth is a strong determinant factor in the quality of your audio recordings. You're also probably wondering, if quality is what I'm aiming for, then why should I still convert my audio from a higher bit depth to a lower one, which clearly reduces quality? That is a good question which we are going to answer step by step in the course of this video, and most importantly, the reason why you dither. At this point, you're probably wondering even more. Does dither once mean dither straight from 32-bit to 16-bit instead of down to 24-bit before going to 16-bit? The straight simple answer to that too is, if you have to dither to 16-bit from 32-bit, then there's no need to first dither to 24-bit before still dithering again down to 16-bit. That would practically mean adding the random dither noise twice, and we don't want that, guys. You're probably also wondering, is it really so necessary to dither my 32-bit file to 24-bit? And the simple answer to that is no. Because the audio quality difference between 32-bit and 24-bit is practically almost indistinguishable. The extra 8-bit added to your 24-bit to make it 32-bit is mostly needed only for extra headroom when processing the audio in your DAW to avoid clipping, among other reasons. Now, you must have also noticed that whenever bit depth is mentioned, sample rate always follows closely. Bit depth, sample rate. These two, bit depth and sample rate, these two are like twins, except only one determines your decision on whether to dither or not, and that is bit depth. But then you dither as the last step before exporting your audio, and when it comes to exporting your audio, you can't talk about bit depth without talking about sample rate. So your next most likely question is, what is sample rate? Sample rate is the number of times per second an analog audio signal is measured or sampled to create a digital file. Your voice is the analog signal going through a microphone to your audio interface and then becoming digital. So take it again. Sample rate is the number of times per second an analog audio signal is measured or sampled to create a digital file. And this measurement is done in hertz or kilohertz. Higher sample rates such as 44,100 Hz or 48,000 Hz capture more data points per second, resulting in a higher fidelity, more accurate representation of the original. So the higher the sample rate, the higher the fidelity of the analog signal is capturing. So how does sample rate work? Let me break it even further. Similar to how video uses frames per second to create motion, audio uses sample to create a continuous waveform. A 44,100 sample rate means 44,100 samples are taken every second. So if your sample rate is 48,000 Hz, it means 48,000 samples were taken every second in the process to capture that signal. As you already know, your audio interface, as the word itself suggests, interface. It is the interface between analog and digital. So it is that bridge between analog and digital. While some audio interface can only record up to 48K sample rate, others can go up to 96K and even above. But then that's already an overkill, as you will still have to downsample before sending out to streaming platforms. Higher sample rates also lead to larger file sizes, which is like obviously because you remember the higher sample rate means it's taking more samples per second, so it's definitely going to give you larger file sizes. And it also requires much processing power for editing. So why does sample rate matter? That's obviously a good question. Using the wrong sample rate or too low a sample rate can cause aliasing. I know you've probably come around this word aliasing. So sample rate matters in that when this signal is captured with higher sample rates, it prevents this aliasing because the signal is captured with much fidelity. Guys, actually we'll talk about aliasing independently some other day in a different video. It's actually a vast topic on its own. So then the second part, which is actually a very important part in this video. What is the connection between bit depth and sample rate with relation to dithering? From personal experience and practice, I always export 3 file formats. And in these 5 formats, bit depth and sample rate are 2 defining factors of what these 3 files are going to be. So generally, I process my audio at 32-bit float and 48K sample rate. But it's very okay to push your sample rate above 48K still. And the instances where it will be okay to push your sample rate above 48K is when you still have to send these files to a mastering engineer. So you want to send your files to the mastering engineer at the original sample rate and bit depth at which you created the files at. So the mastering engineer has these high fidelity files and he or she masters from these high fidelity files just so you can retain the most quality. But if you're going to do the mastering yourself, then to me personally, there's no point recording at higher sample rates like 96K when you're still going to downsample. But then again guys, except your mastering engineer specifically requested for the files to be at a certain bit depth and at a certain sample rate, it's very okay to maintain your files at 48K sample rate and 24-bit depth or 32-bit. If you're wondering what sample rate you're working at because you could be working in your DAW but you're not sure what your sample rate is, you can go to the audio settings on your DAW, and if we go to options, audio, as you can see we're at 48K sample rate. and I'm using a universal audio Thunderbolt which can record up to, what's this, 192,000. This is overkill. So we're at 48K. Let's talk about the different file formats I export, why I export these files this way, and when I dither. So I actually always export 3 different files with 3 different formats. Always. This is like standard procedure all the time. The first file I always export is an MP3 file. And on this MP3 file, I don't change the sample rate, I don't change the bit depth, and I don't dither. This is the file I actually share around, like listen or just test the overall quality of the mix or master. Most importantly, like I said, I don't dither this file because neither the bit depth nor the sample rate has been changed. Now, after my MP3 file, I always export the second file. And the second file is a WAV file. Some people call it WAV, I just call it WAV. I've been calling it WAV for like forever. And on this second WAV file, I don't change the sample rate. I might change the bit depth, most definitely. If I was working at 32-bit float, I'm definitely going to change the bit depth from 32-bit to 24-bit. But I'm maintaining the sample rate at 48K. I don't change the sample rate, I change the bit depth. But then I know you're thinking I'm already changing the bit depth from 32 to 24. So I definitely should dither. And the truth is, guys, I don't dither this second file. Yes. This is the file I send out for anything that has to do with video, TV, graphics, anything that has to do with visuals, because most video editing softwares always recommend a 48K sample rate audio file in 24-bit. This retains the audio quality when the audio gets rendered out of the video software together with the video. For example, I keep this 48K, I come over here, file, export, I could rename it like 24-bit, 48K. And then over here, guys, this is where I change the bit depth. And if you notice, on default, it was already at 24-bit. And as you can see here, the dither option is actually blurred, which is to tell you that we don't actually need to dither this file. But if I wanted it to remain at 32-bit, I could select 32-bit over here. The dithering option is still blurred. If I select 24-bit, the dithering option is still blurred. So I don't dither this second file, you see. Now, if this is just the mix and I want to send this file for mastering, I don't change the bit depth. I'm going to maintain this 32-bit depth. Then I export my third file, which is the only file I dither. Before I export my third file, the first thing I always do is, guys, I always close the project. Yes, first I close the project, I reopen the door on an empty project, I go to the settings over here, and on the sample rate, I change it to 44,100 Hz. You see, so we're downsampling from 48K to 44,100. You can also do this directly from your audio interface console. You see, like with UAD, if I open the console over here, you see right down here we're at 48K, so you can actually change to 44.1K. When I do that, then I choose either to dither directly from my limiter. Remember, this is the only file I dither. So I can come here to my limiter, and on the dither option here, by default the dither option is off. I can now dither to 16-bit. I can choose any of these dither types, basic, optimize, weighted. I just always choose optimize. I could also dither directly from the export window. Wave, we call this 16-bit, 44.1K, 1K sample rate. This is the only time I dither, when I'm going from 24-bit to 16-bit and changing the sample rate from 48K to 44.1K. So now I have a third file format, which is still a WAV file, but it's on 44K sample rate and 16-bit. Now, why do I need this third file and why do I dither? This is the file that goes to DSPs like DistroKid, CD Baby, and whatever. I've forgotten the others. TuneCore, yeah. So this is the file that ends up in streaming platforms, because this DSPs requires your file in this format, and this is called the CD format. So the CD format is 16-bit, 44.1K sample rate, you see. So then we have 3 files, and these are the 3 files I always send out to my clients. If you want to check if your file has the right intended settings after exporting, you can always use the software like Isotope RX. Let me show you actually. Open. You remember I said I always export 3 files. So this first file, if you look down here, right down here guys, you see is at 16-bit 44,100 kilohertz. So this is our CD format. This is the file we actually dithering. Now let's check the other file. This is the MP3. So you see our MP3 file is at 32-bit float and 48K. And I did not dithering this MP3 file. You see there was no need. We did not change the bit depth and the sample rate stayed the same. Now let's check the other WAV file and see. You see our last WAV file is at 24-bit and 48K sample rate. And this WAV file too, I also did not dithering. So this is it. And yes guys, I hope this clears your doubts and confusion on dithering once and for all. Thank you for watching to the end. Please don't forget to like, drop a comment and subscribe, and see you guys in the next video. Ciao.